Hi, good afternoon. I am Jaganmohan from Mlritm. Today we are discussing about fixed and floating point representations in computer system architectures. What is fixed point representation? A fixed point representation is a way to store real number. It will store a real numbers like all are positive values. Numbers with fractions in computer. Those who having number with fraction, it will store the computer. The position of the binary point like decimal point, but binary is fixed. Whatever the number we are having, decimal number is having, after point the value should be fixed. The value cannot be changed. The if it is 26.5 will be there. After point 5 is fixed value. It will be not rotating, like it will not change. It is a fixed value. The number is divided into two. The mainly divided into two parts like integer part and fractional part. It was divided two parts, so integer part and fractional part. Understanding the binary point, we'll do some understanding in the binary point. Binary means nothing but it is a zeros and ones combination will be there, and the binary point works just like the decimal point. It's like just decimal point like that only. And bits to the left of binary point, bits to the left of binary if it is 20.5, 25.6 will be there. Point to left side will be the values will be positive values, and point after point should be negative values. So suppose 25.6 is there. In this 25.6, 25 is the left side will be the positive values and the right side will be the negative values. Here we have to see some small example. See, here have values 2 power 0 is equals to 1, 2 power 1 is equals to 1, and 2 power 2 is equals to 4, 2 power 3 is equals to 8, 2 power 4 is equals to 16, and so on. Like that only it will be 2 power 2, it will be increasing. Like if it is, it will be, we are having one in computer system architecture 8421 process will be there. If it is, it will go left side means it will increase, multiply with the 2, and it will go right side means it will divided by 2. And we need to see, observe the right side values. Here we have to see, we have values 2 power 1 minus 1 means 0.5, and 2 power minus 2 means 0.25, and 2 power minus 3 means 0.125. Here just now discussed about 25.6 value. Point left side values will be considered as a positive values, and point right side values should be considered as a negative values, and so on. Here we need to see like example of decimal example 26.5. Here we are seeing, and 26 point can be converted as a, here we are having 26.5 means here left side values should be positive values, and point after values should be negative values. Here we have to simplify this 26.5. It will be simplified as 2 into 10 power 1 plus 6 into 10 power 0 plus 5 into 10 power minus 1. Here is nothing but 2 into 10 power 1 is nothing but 20, and plus 6 means plus 26, it will be considered as a 26, and a 10 power plus 0 plus 5 into 10 power minus 1 also, it will be total will become 26.5 only. And the binary example we are having, binary code is 110 and 10. 110 is 110 and 10. We have to calculate with the, we are having 8421 process. 8421 process. It will be left side will be to multiply with the 2, right side will be divided by 2, and we should consider we are having 5 digits. Of 5 digits means 2 into 8 16. So we need to see 16 8 4 16 8 4 2 1. We need to say, observe the binary decimal equivalent number is, we are having ones means we need to calculate with the ones. All should be plus, all ones show ones decimal values, we need to add them and we need to calculate them. Here we need to calculate with the decimal equivalent number. Here we are seen 11010 as a 6 decimal binary number. We need to calculate the decimal equivalent number. 16 plus 8 plus 2 plus, right, 16 plus 8 plus 2. Here 20, 24 and 26, the value should be 26. This is the decimal equivalent value, and the binary value is 11010. This can be represented here. Here we need to see the example, and 16 plus 8 plus 2 plus 0.5 is the binary decimal equivalent number. This can be calculated, total is 26.5. Here the decimal example we are seeing. The binary representation means 11010.12. Here 12, why we mentioned 12 means, 12 means here 0.5. We in binary examples we need to 1 divided 1 base 2 we have mentioned means that is a 0.5, like that. And here we need to observe the bit shifting also. The bit shifting is nothing but the bits will flow left or right. We need to see that shift changes will be, shift changes the value of the number. Shift to right means if it is floating fixed point number, it will be left side moving means it will be multiply with the 2. Right side means it will be divided by 2. We just now we have discussed about that. Divides the number by 2. Example 8241, 8421 process we are having now. So that's why if it is we are multiply with 8, 2 4 the right, and 2 2 the 4, and the process will be like that only. And the shift to left means it will be multiply with 2, and 2 the example is here shown like that. 2 into 2 4, 4 into 2 is 8, 8 into 2 16. Move right means, here move right means divided by 2, and move left means multiply with 2. The total 8421 process will be shown like that. If it is left side moving means 2 into 8 16, 16 into 2 32, here shown like that. It will be considered like that only. And a fixed point formal notation is, we need to write fixed point number like this, like fixed w comma b. Here w is the total number of bits and b is the number of fractional bits, binary point position from the right. Number of fractional bits, like a point after right side bits we are having now, that will be considered as the b, and total number of bits we are considered with b, w. An example 8,3 is one of the fixed point representation. The total number of bits, we need to take highest value of the bits, like 8 total bits 8. Here fractional bits 3, totally it will store in integer part 5 bits, it will store integer parts, and 3 bits for fractional part. Example 00010.110.2. Here we need to calculate, here shown like a binary number, we need to calculate the decimal number. See, we are having 5 digits 000 and 10. We need to calculate with 8421 process, right? 8421 process, and one bit is extra, so we need to calculate with the 2. It is called 16 8421. And we need to, what is the ones we are having, we need to calculate the decimal equivalent value. Only we are having one only, so that's why we have to take 2. It will be 2, and right side after it is the integer part, fractional part 110 we are having. Like 8421 process means it will be considered as a 421 process. It will be 4 plus 2, it will be 421. 2 plus 4 6, it will be considered as a 6, and we need to show like this. double one triple zero 10 means 2 plus 0.5 plus 0.25. Here fractional part will be considered as a 0.5. Fractional point, one of the fractional number, one can be called as a 0.25, another one called 0.5, and 0 triple zero 10 we can calculate with 2. It will be completely 2.75. It is equivalent to 2.7 by mostly, right? Here we are calculated the fixed point, one of the example. And the sign numbers, and sign numbers means it is the positive and a negative will be there. Computer stores everything as a bits. Computer can stores, if it is whatever we are giving the memory, that will be data will be stored in bits. Bits contains flip-flops we are having data. Like they don't use like sign like math, it will be don't use like symbols like mathematical applications. There are three ways to represent negative numbers. Here we need to represent three ways for negative numbers. First one is sign magnitude num form. First bit, MSB bit, is equals to sign. MSB bit, most significant bit. Most significant bit, most significant bit is nothing but it is the first bit of the register. If it is first bit of the bit, 8 bit of the register we are having, 0 to 8 bits we are having like this. 0 most significant will be there, and least significant bit will be there. Last bit is last bit we are consider with the last least significant bit, and first bit will be considered as a most significant bit. Here most significant bit will be positive. 0 means it will be positive number. It will be 1 means it is the negative number. Remaining bits magnitude, here these called magnitude. If it is a 8 bit of the register, it is called magnitude. It will be called as a magnitude. Example of 8 bit register we need to take. Suppose we are taking 55 consider as a binary number here, and minus 55 we are having binary number. We need to see the example problem. Two zeros exist, plus 0 and minus 0. One's complement form. One's complement is nothing but here we are having any binary number, we need to do ones can be 0, zeros can be 1. It will be reverse order. So negative number is formed by the inverting all bits 0 to 1, 1 to 0. Example 55, we are seeing the binary number 0 double 0 double 1 0 triple 1 here shown here. If it is we are done one's complement means it will be 0, 2 zeros are came, it can be converted as a 1. Double 1 convert with 0, and 0 can be converted as a 1. 0 triple 1 converted as a triple zeros. This is called one's complement. One's complement. If it is positive number can be converted as a negative number means it will be converted as a one's complement. Minus 55, still two zeros we are having in the like plus zeros we are having, and minus zeros are also having. We need to do 2's complement method. 2's complement method is used for the problem. Steps to get negative number: take one's complement inward bits, and one's complement means we here converted as a one. Zeros can be converted as ones can be converted as a zeros. And after 2's complement means it will be after one's complement we need to add 1. If it is here we added 1 like double 1 0 0 1 triple 0, here we need to add 1. 2's complement means we need to add 1. Though the result should be considered as double 1 0 double 1 1 double 0 1. Here these called 2's complement. Here we represented that only. If it is 1's complement also done and 2's complement also done. And so minus 55 can become double 1 double 0 1 1 double 0 1. The advantages is only 1 0 and easy arithmetic operations, mostly commonly used in computers. And then the next topic is floating point. We need to see what is the floating point. Floating point is a way to store very large and very small numbers in computer. It can store very large numbers means 10 power 10, 10 power 9. It will store 10 power 9 means it will be the amount will be greater than like crores or thousands lakhs also. And here we need to see minus negative small numbers also like 10 power 1, 10 power 2 and minus 1 numbers also it will store the computer. It is based on scientific notation. Example, here we need to see like 4500. Here the floating point will be stored. It will be continuously changing whatever the exact input we are giving, that will be changed through the floating point. Like 4.5, the formula, the 4500 converted as a 4.5 into 10 power 3, it is also called 4500. In the binary computers, the number will be divided as a sign bit as a first part, it will be considered as a first part, and into mantissa and 2 power cap exponent, it will be 3 parts will be having in the floating point. And the basic formula is sine into sine significant mantissa and into base exponent, where sine 0 is equals to positive number and 1 is equals to negative number. Mantissa is significant precision part, base usually 2 binary, and exponent power of 2. Minimum value should be minimum power of 2. Why we need floating point? It can store very large numbers like 10 power 9, and it can store very small numbers also like 0.00001. And a good balance between range and accuracy, it will give good accuracy and good range, used in scientific calculations for graphics and engineering and AI simulation. Here precision times here shown like that. If it is single precision 32 bit means 32 bit register, 64 bit register double precision, sign bit is 1 bit, and exponent will be 8 bits, and mantissa will be 23 bits. 8 bits means nothing but the exponents means that the power will be 8, and the mantissa will be the data register MSB bit after. The register contains 3 parts. Now we are having MSB bit and mantissa and LSB, least significant bit. The mantissa will be 23 bits, and the LSB bit contains like 1 bit, sign bit contains 1. And here double precision also MSB bit contains, and mantissa contains 11 bits, exponent contains 11 bits, and mantissa contains 52 bits. It will be located in register only. Like first bit we need to tell like most significant bit, last bit we can say least significant bit, in middle part of the content we can say mantissa. Decimal floating point number, example, convert 17. A floating point is nothing but the value should be changed. The value we are giving this a decimal point, it will be converted into system understandable language. It will come through power only. Like step 1 sign number is negative. Here came 17 means first value came 1, so that this can be negative, sign bit 1. Step 2, convert 17 into binary. The 17 can be converted to binary numbers. We are having zeros ones code now, that will be called binary code. The binary is 10001. Here 17 means we are having 16. 17 means we have to take like 8421. Again we need to take 16, right? We need to calculate with the 16 decimal equivalent number means those who are having in binary numbers, once we need to calculate with the number decimal equivalent number, 1 in 16 place having, and 1 place also having, so that's why 17. It will be binary number should be 10001. So that will be calculate 17 is equals to 10001. We need to normalize the given problem. 1.000 into 2 power 4, it will be converted as it will be calculated as a 17 only, and here exponent is power value that is the 4. And add biases, if it is negative number means we need to add bias 127 to the exponent. 127 plus 4 is equals to 131. This is the default. Add bias value is default in the floating point. Add bias 127 is the fixed value. Floating value that can be converted as a 131. 131 binary number is the 100 100 500 Here this much means we need to calculate with 8421, right? 8421 is we need to calculate with 2 into 8 16, 16 into 2 32, 32 into 64, 64 into 2, 64 into 2, 2 4s are right, 2 6 are 12, it is called 128. The value is 131. 128 we need to take plus 2, 2 means 2 and 1, 130, 131. These the 10001 binary number value, binary number, that is a decimal equivalent value should become 131. So this is for the convert 17. For convert 17, the result will came 100000011. These can be these two are the floating point and fixed point representation. Thank you very much.